Hey, good evening, everybody. Hope everybody's having a great day. My name is Lieutenant Bob Roberts. I'm with the Greenville Composite Squadron here in Greenville, South Carolina. And we are here for AE Live. Since we cannot meet in person at our squadron, we are doing these videos live on YouTube. And so if you're a member of my squadron, it's nice to virtually see you again. Feel free to go ahead and post your hi in the comments section on the side. Or actually, it'd be that way. And if you're from outside of Greenville and you're not even part of CAP, feel free to say hi as well. Tonight we are going to be talking about the Artemis program. This is going to be taking us back to the moon. Very excited about this. But before then, as always, let's go ahead and start with some housekeeping. So really have two things in housekeeping. Number one is I am looking at possibly doing a ground school video series for people that are flight simulators. We have a new Microsoft Flight Simulator that's looking to come out later in the year. A lot of people, their first foray into flying is actually through a flight simulator. I know for me, when I was a teenager, that's how I started learning how to fly, was through a flight simulator. And it really did help. When I actually got into a real airplane, I knew what the instruments did. I knew how they reacted. I knew how to do basic controls of the airplane, and that really did help a lot. So if you are all interested in doing some ground school, unofficial FAA ground schooling, and with the understanding that it's for flight simulating, so you can take your flight simulator training to the next level, then let me know in the comments down below. That would take a lot of work, but it'd be something I'd be interested in possibly doing. So let me know if that's something that you would find useful. The second piece of housekeeping is that Aerospace Dimensions Module 2, Chapter 1 is going to be up online this Friday, putting the final touches on it, and you should see it on Friday. We have already completed Chapter 2 of Module 2, so this will actually complete all of the chapters for Module 2. And that means that we now have completed Module 1 as well as completed Module 2. So with that, let's continue on to the news. All right. This actually, I thought we had some really good news stories this week. So the first news story was actually about the moon. And actually, let me give you that PowerPoint. There we go. Hang on. That's not right. You're not seeing the right screen. Hang on. We have technical difficulties, but we're going to fix this as we are live. Hang on. Because we can do this. I don't know why it's showing that one. That's interesting. That's not it either. Uh-oh. All right. Let's, sorry about this. I actually did test this beforehand. So let's try this from the beginning. Uh-oh. Bum. Window capture. Automatic. Uh-oh. Oh, there we go. I think we're there. Let's see. Oh, why isn't it updating? This is what happens. This has been working the whole time. Now it's not going to work. Okay. Do me a favor. Go ahead and chat. And somebody cause me some a delay here while I'm figuring this out. See, that's showing that, but I don't want the whole screen. I mean, if we have to, that's what we're going to do. We're going to show this. But I would prefer not to show this. All right, you know what? Give me one more minute. And what I'll do is I'm going to remove all of this. Nope, that's not it. It just does not like me. Hang on. I don't know if the software made an update. Oh, hang on. Is this good? No, no good. All right, I'm going to show the other one just for sake of time. My apologies on that. All right. So let's get rid of this. All right, here's the housekeeping slide that I did have up. And I will fix this after today. All right. So in the news, and actually, I have to make this a little bit smaller. Oh man, this is not doing good tonight. My apologies. All right, let's make this bigger. All right, it doesn't like that, so let's do this. Okay. All right, screen's gonna be a little weird tonight. My apologies. So, see, unfortunately, I think when I do this, it's not going to even show the slides, the video presentation. But we'll see if we can get through this. All right. So the first news story that we had is that the ridges on the lunar surface actually showed some recent tectonic activity. And so what that means is, if you know about the Earth, right, the crust is sitting on a ball of lava, right, and so things move around on the surface of the Earth, because inside the Earth, it's not dead. It's not just solid, mass, right? It's liquid. It's alive. It's moving, and the surface moves around. Floats on top of it. Now, we didn't know that about the moon, right? People had theories, and there are still theories, but but on the moon, we just thought, it's pretty dead. But we're actually finding clues now that's actually not the case. That relatively recent, now relative in space terms is a really long time, right? But relatively recent, we can see evidence that the crust of the moon has moved. And so what that would indicate is that that underneath the crust of the moon, it may not be solid either, or at least it wasn't at one point relatively recently. So that's some interesting science that they're going to be working on. Our next thing is that, let's see here, play. Can I do this? Yeah. All right. So we now have a name for our helicopter that's going to go to Mars. It is going to be called Ingenuity. And so what happened is there was a contest to name the next Mars lander, the Mars rover, and that is called Perseverance. And what they did, rather than having another naming contest, NASA kind of went into all of the suggestions, and they picked another name that they liked, and so they picked Ingenuity. And so congratulations to 11th grader here, Vanessa Rupani. Hopefully I said that kind of close. Apologize if I got that name wrong. So this is pretty exciting. So this is the Mars rover. So, the Mars helicopter. So now with Ingenuity, what's so interesting about this is there's very little atmosphere on the surface of Mars. And so this is, this isn't like a normal drone. It has to be incredibly lightweight, and those propellers have to be incredibly strong in order to be able to lift it up. So that was an interesting news article. And our last one. Now, I actually did a standalone video on this earlier in the week. And so Harrison Ford, this is his second time he had kind of a boo-boo with the FAA. One time he landed on a taxiway. Actually landed over another airplane. I think it was a 737. And he landed over top of that airplane and landed on a taxiway. And then he actually asked the controller if that airplane was supposed to be there on the runway. So he totally confused that one. And then now this last week, the previous week, he went to the end of the runway and he was told to hold and not cross the runway. And then when he actually crossed the runway, he told the air traffic controllers, "Hey, I'm still holding," and then the air traffic controller said, "Continue to hold." Well, he misheard that, and he thought that, in his mind, he heard cleared to cross the runway. So he went ahead and crossed the runway. He actually acknowledged back to the FAA controller to cross the runway, and the air traffic controller immediately jumped on him, said, "What are you doing? You got to get off the runway, now. You got to listen." So I actually did an entire video on this. Feel free to go back and look at my YouTube channel. You can see that. I'm only going to play an excerpt of this because I did want to talk about it real quick. So let's see if I can get this to work.
Runway 25 and 2607. Cleared land.
89 Hotel Uniform.
Husky 9 Hotel Uniform, turn left Delta, runway 25, taxi is 0 with me.
Okay, left on Delta, taxi on Sierra with you, sir.
Husky 9 Hotel Uniform, paying attention.
GBH hangar.
Husky 9 Hotel Uniform, hold short runway 25 at hotel.
Hold short of 25 at hotel for 89 Hotel Uniform. 89 Hotel Uniform, hold short at hotel.
Hotel Uniform, can you hold short runway 25, traffic on the runway?
Crossing 25. 89 Hotel Uniform.
9 Hotel Uniform, get across that runway now. I told you to hold short. You need to listen up.
Excuse me, sir. I thought exactly the opposite. I'm terribly sorry.
Now here's a chart of the Hawthorne Airport. Okay, so in the video that's on YouTube, I actually go ahead and I break this down even more. I go across the actual runway, what happened. So again, if you're interested in learning more about runway incursions, feel free to go ahead and watch that video. I just put it up last week, so it's easy for you to find. All right. Now on to our main topic for today. We are going to talk about the Artemis mission. So we have a bunch of videos as part of this larger presentation. It's going to be less of me talking. There'll be more video. And so hopefully you enjoy that. NASA has put together some really great videos on this. And when we get to the end of the presentation, we're actually going to do a walkthrough of the mission. There was a really good chart showing the walkthrough. So we are going to walk through it. So here is the first thing I want to start off with is even though this is an old video, I think it speaks just as much to today as it does to the Apollo program, going on 60 years ago, 55, 60 years ago. Now, obviously, when the Apollo program came out, we were in a competition, right? Competition drives human beings typically. And so we were in a competition with the Russians to be the first to the moon. And we kind of won that, right? I mean, Russia, to my knowledge, has never been to the moon. China has never been to the moon. So because of that, we won the game. And unfortunately, we stopped playing, kind of, right? We played the game a couple more times, I think 6 missions to the moon, and that was it. We kind of decided, okay, we did it. So we stopped playing the game. So what's interesting about this one now is that we are no longer just looking to go to the moon. The moon is no longer the game. The game is Mars. And so, now the moon is just a stepping stone. It's about relearning how to do longer term flights, how to do our builds, and how to make sure everything's working good, and how to land, when it's not on the Earth, things of like that. So here is the famous speech by John F. Kennedy.
William Bradford, speaking in 1630 of the founding of the Plymouth Bay Colony, said that all great and honorable actions are accompanied with great difficulties, and both must be enterprised and overcome with answerable courage. If this capsule history of our progress teaches us anything, it is that man in his quest for knowledge and progress is determined and cannot be deterred. The exploration of space will go ahead. Whether we join in it or not, we mean to be a part of it. We mean to lead it. For the eyes of the world now look into space, to the moon, and to the planets beyond. Our leadership in science and industry, our hopes for peace and security, our obligations to ourselves as well as others, all require us to make this effort, to solve these mysteries, to solve them for the good of all men. There is no strife, no prejudice, no national conflict in outer space as yet. Its hazards are hostile to us all. Its conquest deserves the best of all mankind. We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
Okay, so so back then it was we choose to go to the moon. I think that speech is just apt now as well. even though that was a 60-plus-year-old speech by John F. Kennedy. Now, it could be we choose to go to Mars. And so, again, we are going back to the moon, but we're going to prepare to go to Mars. That is the goal, to learn how to land. Rovers. We've already been landing rovers on both the moon and Mars, but these are going to be bigger. These are going to be bigger landings. They're actually going to have supplies. We've been landing things that are the size of a large pickup truck. But now we're going to be landing things that are significantly larger than that, because we're going to be landing supplies and science experiments, things of that nature. All right, so next we have a video that's going to explain. I wish I could show this full screen to you. We are going to, all right. And this is going to talk about the Artemis mission in total. This is a little bit longer. I think it's about 4 minutes longer, so we'll see at the bottom once it starts.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources,
we're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable,
that can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going. We are going. We're going.
All right, so they are going. We are going too, and you know, especially for our cadets, you're at an age where you push yourself, maybe you're going to go. So anyway, so here is, the first step of that was our space launch system. And so this is the rocket. Now we're used to talking so much about the Saturn V rocket because that was the massive rocket that took us to the moon through the Apollo program. And for some of us, we actually just watched the Apollo 13 movie together. So here's some stuff that I thought was interesting. So the SLS is exactly 1 meter taller. And I just find that hysterical. It's like somebody said in a boardroom, in a meeting room somewhere, that, hey, listen, we have to be bigger. We have to be bigger than the Saturn V. So they have a tower that sits on top, right? An escape tower, a pole motor tower. And so, they didn't have to make it 1 meter taller than the Saturn V, but they did. Anyways, the second thing is that the Saturn V weighs 5.5 million pounds. I'm sorry. The SLS weighs 5.5 million pounds. The Saturn V weighs 1 million more pounds than the SLS. So SLS weighs 5.5 million pounds, and the Saturn V weighed 6.5 million pounds. But even though the SLS is 1 million pounds lighter, it actually generates 8.8 million pounds of thrust, which is actually 15% more thrust than the Saturn V. So even though it is lighter by quite a bit, almost 20 pounds lighter, 20% lighter, it has 15% more thrust. So that's pretty great. Here's one other thing I thought that was interesting. So if you look at the bottom right chart, you'll see the Falcon Heavy. You'll see that it is much smaller than both the Saturn V and the SLS. And it can get 5 million pounds of thrust. So 5 million pounds of thrust is, 3.8 million pounds of thrust lower than the two big rockets, than the SLS rocket. But so it doesn't have as much thrust, doesn't have enough thrust to get the spacecraft into the moon or to Mars. One thing I thought was interesting, though, when we talk about the use of the Falcon Heavy, is it's still 5 million pounds of thrust, which is huge. And it costs just 10% of what it costs to fly what they're estimating to be roughly $900 million per launch of the SLS rocket. And that's their current estimate, right? So that's probably going to be $1 billion or more when they're done with it. And SpaceX right now is launching the Falcon Heavy for about $90 million. So that goes to show you the power of reusability. Since SpaceX doesn't throw away their rockets when they're done. We're going to spend $1 billion on an SLS rocket, and it's going to be thrown away. So I thought that was interesting. All right. So if we take a look a little bit closer at the SLS rocket, we can see that very similar to the space shuttle, it actually has two solid rocket boosters that are flanking a center core. The Saturn V rocket did not do that. It was just a center rocket with a two-stage. And then you'll see the core stage, which has 4 RS-25 engines in it. Then you'll see an interstage. Now, the interstage is really there just to receive and hold the upper stage, right? So if you remember in a lot of other conversations on rocketry, once that center core and those solid rocket boosters are used up, you don't want to continue to hold all that mass, right? Because you have to move that mass. You need force to move the mass. And so there's no sense of having it. You just throw it away. And that's actually one of the benefits of using the solid rocket boosters. When they're used up, they just go away. Just go away. So some people would say this is a 2-stage rocket. I would almost say this is a 3 or 4-stage rocket because you're jettisoning these two rockets here. You're going to get rid of those. And so that's a stage almost into themselves. They're just launching at the same time as the center core, so it's still one stage. But anyway, so the inner stage is really a holder for the upper stage. It will come off, and that will release the upper stage. The upper stage then will launch. And then there is a payload section. They actually are talking about being able to launch instruments on the way to the moon or even around the moon itself. Above and beyond the actual landing capsule. Now, they couldn't do this with the Saturn V because the Saturn V didn't have as much thrust. and weighed more than this rocket does. But here they actually have the ability to take up a little bit more payload. So they're going to be doing that. And then they have the adapter ring and the fairings. And then finally, you have the service module and the crew module. So once again, similar to my conversations around the Saturn V, it is really quite amazing that all of this is really just to get this little tiny piece to the moon and then to Mars. And mind you, this is not what will be going to Mars. We'll talk about that probably in a second. But they only have an in-flight rating for 21 days. So the crew module is only rated to be manned and flown in space for 21 days. All right, so let's go here. I'm not going to go through this picture. This would be much better if it was full screen. You'd be able to see a lot better. But this goes through the same thing. You can see the solid rocket motors, and the center core, and then the secondary upper stage motor, and then finally the crew compartments and the service module, and then the tower, the launch abort system. All right. Now, once we get this thing up there, the thing that's going to be most important is the Orion spacecraft. This is the whole point of this big rocket, is to get the Orion spacecraft up into space. And again, as I mentioned before, this thing can be up there for 21 days when it's undocked. So basically when it's flying by itself with the astronauts inside of it. When it's docked, it can power and run for about 6 months. So it is possible that this craft could be part of a longer mission. But right now, when it's not connected to something else to help it with supplies and power, it can run for 21 days. The Orion spacecraft has one AJ-10 engine, and the RFD-11, and then it has 6 pods of custom reaction. Those are the little tiny rockets that are off to the sides, usually compressed gas of some sort, that help to steer it once it's in space. But the AJ-10 engine is the big engine that will really push it forward. Here is an actual picture, because obviously the other video that we haven't flown this thing in space yet, so that was just a CGI image video. Here's an actual picture of it pretty recently. They have now put a skin on top of it, so it looks a little bit more polished. But this is before the skin was applied, and so you can see how many actual tiles there are. People will see a lot of spacecraft and they think it's just a solid piece of metal, or it's tinfoil on top. It's very complicated underneath that housing. All right, so this next one was also a full frame video, but I wanted us to watch this.
Apollo led the way to the moon, and we, the Artemis generation, are going there to stay. Those of us in blue flight suits, the start of the Artemis generation of astronauts, could not be more excited about contributing to our nation's goal of putting the first woman and the next man on the lunar surface by 2024.
We, NASA, have been partnering with U.S. industry in order to achieve the best of what each organizations bring. So without further ado, the companies are SpaceX. The SpaceX design is...
I actually want to stop. I'm going to talk about each of these. This announcement actually was last week. So this was actually pretty exciting last week. There's 3 winners for the initial development. SpaceX being the most futuristic looking of them. I will say I have 2 concerns. As much as I'm a fan of SpaceX, I'm a huge fan of SpaceX and what they're doing. A lot of things that we're doing right now in space are being pioneered because of them. But I'm concerned about 2 things from this design. Number one, it's very tall and it's not very wide. And so I'm worried about if it lands on a surface that is not very flat. I'm worried about the fact that it might tip over. There's smart people smarter than me, I'm sure they see that too. And there's not as much gravity, but at the same time, physics is physics. So if it's on an angle, it'll fall over. The second thing I'm a little concerned on, and we'll see if they show a picture of it.
Is a single-stage solution using their Starship. The SpaceX...
Okay, so they do show a picture. So the other thing I'm concerned about here is they need a crane elevator, at least in this current iteration, to get them from the spacecraft all the way to the surface. So two things. One, I hope that doesn't break, because if it breaks while they're in the spacecraft, they're going to have some sad astronauts that got to the surface of the moon, but probably don't have a way to get onto the surface of the moon. Or worse, if they're on the surface of the moon and that breaks, and if there's not some other way to get them up to the top. Again, there are people that are much smarter than me that are going to obviously see that and start working towards that. But I thought that was two interesting items.
Proposal included in-space propellant transfer demonstration and uncrewed test landing. The second company is Dynetics, and Dynetics has many partners that they will be working with. It also has a very unique low-slung crew module, putting the crew very close to the lunar surface.
So this one I think is interesting. So what she is now saying is the exact opposite of the SpaceX rocket. So maybe this is in NASA's mind too, is that Dynetics, they're like just, a hop, skip, and a jump, right? It's almost like the old Saturn V Apollo capsule, where they, he can just hop off the little ladder and, they're really low to the ground. Now this is a lot wider. So this is almost a polar opposite of what SpaceX was. That being said, the SpaceX, you can just tell by the astronauts that are next to it, the SpaceX lander is much bigger. So it'll be able to house a lot more fuel, a lot more scientific instruments, hopefully a second elevator in case the first elevator breaks. Maybe get since this is May 4th, right? Star Wars, May the 4th be with you. Maybe they can get one of those, Boba Fett rocket packs and, blast themselves up to the top if the elevator breaks.
For transfer and access, Dynetics will perform a demonstration flight to verify key capabilities for its lander system. And the third team is the national team, with Blue Origin as the prime. The team's design is a three-stage architecture consisting of an ascent, descent, and transfer elements. With this
So they call it the national team, but there should be no doubt that is Blue Origin. Blue Origin is Jeff Bezos. Jeff Bezos owns Amazon. So make no doubt that this is going to be a race between Jeff Bezos and Blue Origin, as well as Elon Musk and SpaceX. And then you've got Dynetics sitting in the middle. So you don't know. Maybe Dynetics is actually going to win this thing. That'll be interesting. So Dynetics, they're a much smaller company than obviously SpaceX or, an Amazon-funded Blue Origin. Now, the other thing I think is interesting too is, Blue Origin, as exciting as they hopefully will be with the New Shepard rocket, they haven't done it yet. It's a lot of cool videos, a lot of cool talks. They don't have anything that's gone into space yet, into outside of anything low, really low Earth orbit. And then, meanwhile, SpaceX has been constantly just getting there. We talked last week about their serial number 4 successfully passing its cryogenics test. So they're working it. And all of those successes, that gives you more and more momentum and more knowledge. The people that work there, they're not just talking about going to space. They're in space. They have active missions in space. And so that's to me, that gives them a pretty good leg up. I am really interested in Dynetics. I will admit. It's kind of like the little rocket company that could. So good for them for at least getting in the running here to be one of the final 3 that have been chosen. All right, so let's take a look at the first couple of missions that we're going to have. I'm going to be looking away from the camera for a second because I'll be looking at the screen myself. So obviously Artemis 1, that's going to be the first time that the spacecraft goes to the moon. I don't believe there's going to be anybody on it. That's just going to be testing the spacecraft, making sure that it can actually get to the moon. Artemis 2 is going to be the first humans are going to be in the spacecraft. I do not think that they are going to touch down. Similar to the Apollo program, they're going to just be people there. They're going to go around the moon and then come home. That's probably really disappointing to them, but hopefully we'll have a lot more missions and those people will get back and actually get a chance to walk on the moon and hopefully walk on Mars. And then we have a couple of support missions to look at solar electric propulsion. And here we're talking about delivering modules to the Gateway. Now, one thing that has changed, a news article came out a few weeks ago, probably after they made that video, is that NASA has said that they are no longer going to have Gateway as a milestone going to Mars, or sorry, to the moon. They're going to be launching the Artemis missions before Gateway is ready. They may still put Gateway out there, but I think that they're worried that Gateway may actually take longer to build and to certify than the actual Orion capsule and the SLS launch system. So anyway, so when we get to Artemis 3, that should be the first time that we all get to sit around a TV screen and just stare in fascination as humans once again are landing on and walking on another planet, another surface other than the Earth. So that'll be very exciting. That is right now scheduled to happen in 2024. I think it's unlikely that they'll probably make that, if it's my opinion. NASA is still saying 2024, but they're already about a year and a half behind on the SLS rocket. That SLS was supposed to launch this year, and I think right now they're saying it's November of next year. So I think they're about a year and a half behind. So our last slide, and we're going to go through this relatively quickly. This is a busy slide, especially since this is going to be smaller on your screen because my PowerPoint presentation didn't work right with the streaming software. So I'll go through this relatively quickly. If you have any questions, this would be a good time to put your questions out there, and then I will hide this screen and I'll take a look for the questions. And I'm going to make a decision probably tomorrow because we had so many technical problems with this video. I may actually make a non-live version of this video, and I may put this up on, I may put the non-live version up and replace this technology deficient version that we're doing tonight. So if you wanted to see some of this, some of these screens in bigger detail, or some of these videos in bigger detail, check it out like maybe in a couple of days or possibly over the weekend. I may actually replace this live video with a pre-recorded video. All right, so obviously step one here, we're going to launch the SLS, and Orion is going to lift off of 39B. That is the same launch pad that actually a couple of rockets, the space shuttle, the Saturn V, as well as the Falcon Heavy. They all use that same pad. So it's a very popular, very historically prominent pad at the Kennedy Space Center in Florida. And when that happens, if you want to go, let's get a big bus. Let's all go and watch this thing. It's going to be amazing. All right, so this thing's going to take off. It's going to jettison its rocket boosters. Again, the solid rocket boosters are on its side. They will separate off. One thing that's interesting is that solid rocket boosters versus the liquid rockets, once you turn them on, there's no turning them off. That's one of the risks you have with it. You tell those things to go, you're gone. You're going. The only way to get off it at that point is to have that top cone pull yourself off that rocket. All right, so the jettison, and actually just speaking about the launch abort system, LAS, once they get to a certain altitude where it really won't make sense to have the launch abort system, they're going to get rid of that. And again, previous to the conversations, right? So we have the side boosters. Once they're all used up, no sense of carrying around the weight. So get rid of them. The launch abort system doesn't weigh all that much, but again, it's still mass. So once it's no longer needed, get rid of it. No sense of using any force to try to do that. And then the core stage main engine is going to cut off. So that's the main orange body. And then it will separate. That middle section will come apart. And then the bottom rocket will fall back and it'll burn up in the Earth's atmosphere. Maybe someday they'll make that thing so it can re-land itself the way that the Falcon 9 can reland itself. And then it's going to enter Earth's orbit. It's going to go around Earth a bunch of times. They're going to check it out, make sure everything looks good. And, you know, this is the time where if something's wrong, you might as well get the thing back on Earth, you know, rather than try to start going to the moon when there's a problem. You know, we had Apollo 13. We don't need Artemis 3 as another movie 25 years from now. All right, so then, you know, we're going to, once they have all their checks done, then they're going to launch the main rocket. That burn's going to be about, what does it say here? 20 minutes that rocket's going to burn for. And then they are going to, they'll be on their way to the moon. The whole time that they're going to be going to the moon, they have little motors that will adjust its trajectory. And if they have to, they can reignite the main motor to give it a bigger boost if it needs to change its orbit. Once it's done by that, it's going to fly by the moon. It's going to start putting itself into an orbit around the moon. Then depending on what the mission is, whether they're just flying around it or whether they're going to land on it, they may do a deceleration burn, which means it actually would turn the rocket facing the other way from where it's heading. They'll launch the rocket motor, and that will slow it down, and then the gravity will slowly pull it into the moon. When they're done, they just hit that motor again and on their way back to the Earth. And they'll do a final trajectory correction burn. I know in the Apollo 13 movie, they made it seem, you know, it was a movie, right? So they have to make it exciting. So they made it seem like, you know, that last burn was a really big deal. And it was a big deal because they had to do it manually. But if you've read the books, there's a really great book. I don't have it in front of me. There's a really great book about that. And the astronauts basically said that was really for the movies. That really, it wasn't that big of a deal. It was a pretty normal trajectory correction burn. They have to do it all the time. So anyway, so the Artemis will do that as well here. And once you get a little bit closer to the Earth, you can really pinpoint in, because you have to be right on it. As the movie said, for those of you who watched the movie with us, you know, it's really thin. It's like paper thin when you look at the size of the Earth. You've got to hit this real thin line so you don't just skip off the Earth's atmosphere, or you don't come in too hard, get too fast, and then you get too much heat and burn up. At that point, it's just like the Apollo program. They have a heat shield on the bottom, and they will land someplace hopefully nice and warm, and we'll get them out, and that will be Artemis 1. And actually, this was specifically talking about Artemis 1. So this is one where we don't have any, there will not be any astronauts in Artemis 1. But when we get to Artemis 2 and 3, it'll be a very similar thing, but it's going to, it'll have people in it. Artemis 1 will just be automated. It'll be just to make sure everything's working. So, okay, so that is, for the most part, our presentation tonight. All right, so let me take a look to see if you guys had any questions. Again, sorry for the technical difficulties in the beginning. I'm not sure what happened there. This has worked pretty reliably the whole time. All right, let's see here. I see a bunch of folks, and they're saying good evening, and good evening to all of you too as well. Let's see. I don't see any questions, so we'll give it a couple of seconds. And I hope everybody's doing good. I'm hoping that, you know, right now we're going through the great American, you know, lab experiment by opening up some things, and we're going to see how that works. And, you know, fingers crossed it works well for everybody, and we can get our meetings back in Greenville again. So, okay, I'm not seeing any questions, and I'm actually seeing some viewers dropping off. So I think that wraps it up for tonight. So thanks, everybody, for joining again. I will probably be redoing this video once I can figure out how to fix this. So if you wanted to see any of these videos or charts in bigger screen, feel free to go ahead and check us out sometime probably after this weekend. I'll probably redo it over the weekend. Okay, thanks, everybody. Have a great night. Bye.